All right, this is our Section 5 Enrichment Practice, which was given and worked on all day in class Friday. If you missed our last day of school, which was Tuesday, you did not get an opportunity to go over the answers. These are each one of the problems. We have made some adjustments to it to only highlight the ones that will be on our test, which of course we know is going to be December the 1st, which of course is Tuesday. So starting with number 1, we want to look at triangle BAE, and we trace BAE, and I'm just going to cover it up so we can see BAE. And when we look at that, we can see that it is indeed a right triangle, so unless this one goes ahead and focus. And we can also see that there are 3 different markings, therefore giving it all 3 sides a different measurement. So therefore we know that there's going to be a right triangle, and it is also going to be scaling. So this will be a right scaling triangle for triangle BAE. Triangle BED, if we cover this up, we can see that it indeed has 2 markings that are that are identical, so we know that it's going to be isosceles. And we also know, because of the neighboring one, which is going to be, of course, an equilateral, we know that, of course, all the angles and sides of this one will be equal. So in this case, I know that each one of these angles are 60 degrees. If I needed to figure out what this one is, since this one is 60, I could just subtract that from 180 and solve and know that this one would be 120. In doing so, I know that I could identify this triangle by its sides, calling it isosceles, and also by its angles, having one angle that is going to be obtuse. So we know that this is going to be an obtuse isosceles. And of course, we've already given the answer for this last triangle. We know that it's going to be equilateral, and we know that an equilateral will also mean that it is equal angular. Please make sure that you select correctly. No matter how many triangles are listed up here, you need to know your triangle combinations. Please make sure that you take your notes that we did on classifying triangles, and please review that. So no matter what kind of triangles they ask you, you'll be able to find. So let me show you what your classifying triangle notes look like. So here are your classifying triangle notes here, front, and the examples that we did together on the back side. So please make sure you review those. Okay. All right, the next thing that we're going to do is look at our proof. Question number 3. I'm not doing question number 2 because it is identical or very similar to question number 1. This is going to be a drag and drop. So all of this is multiple choice up here. So what that means is that you're going to click on the box, and you're going to drag it down to wherever it's supposed to go. I would suggest to you that whatever your shape is, you draw it on your picture so that you can mark it carefully and select the right answers. So the very first thing we're going to do is look at what was given to us, and we get lucky because the side AB and side DC being congruent, and side AD and side BC being congruent is given. We also get the AD and BC being what we know as parallel, and then of course AB and DC of course being parallel. Okay, so that's going to help us in going through our reasoning. When we look at our picture, there's already some markings there, and therefore we don't have to mark it. So they've already marked our congruent sides to each other. All right, so nothing to do quite yet. we go over and look at our statement and see for our statement, it is indeed the very first thing that we have, which is going to be given. So when we take this test on the computer, you're going to click the given and drag it down to your number 1. In this case, of course, we have to write it as this is paper. Okay. So we have our given. Our next thing that we're going to do is mark the angles in which we have been given in our statement. We want to do that so we can select the right thing. So when we look at this angle ACD, always know that the most important letter that we want to choose is going to be, of course, our middle letter, which is C, our vertex. So after we trace it, we're marking our angle where the vertex is. So tracing this ACD, then this is going to be right here. When I trace CAB, I'm going to mark it here. All right. So those are one set of angles. If you notice already, they're appearing on opposite sides of the line cutting through the middle, which will be, of course, our transversal. We'll talk more about that momentarily. And then we're going to see that we have a BD, so we trace that, A, B, D, and we mark it. I need to give it 2 markings because I don't know if they are congruent to each other. It does not say that all 4 of them are, so I want to give them a different marking. And then we go to CD, B, which again I'll mark here with 2. I'm going to go ahead and extend the parallel lines of AD. And remember, we call these auxiliary lines. And I'm also going to extend this particular transversal and this particular transversal. In doing so, what I should clearly be able to see is that with these parallel lines, I have angles that are on the opposite sides of the transversals, of the 2 transversals. So we know that when we have parallel lines and the angles on the inside are on the opposite side, we know that these are going to be what we call alternate interior angles. So that's what I'm going to write down. But if you notice in your multiple choice, there is no alternate interior angle just by itself. What you do see written there is going to be if 2 parallel lines, if 2 parallel lines are cut by a transversal, then your alternate interior angles are going to be congruent. This is going to be the box that you're going to drag down. What we're going to be looking for is that alternate interior. So I'm going to write here, alternate interior. So now that we have our alternate interior down, the next thing that we want to do is look and see. This symbol in the front means triangle. We have now gotten to the point where we can try to figure out why triangle ABE is going to be congruent to triangle CDE. Now, it might be difficult to see triangle ABE, so what I'm going to do is just redraw it, just one of them, not both of them. So that we can kind of just concentrate on one. So we know that this angle had a marking, we know that the side had a marking, and then this angle as well had a marking. So based off of our markings, and as you can see, all I did was redraw this triangle here, we can clearly see that we have angle, side, angle as our selection to y, our triangles are going to be congruent to each other. So what we would do here is look at our answer choice, click that and bring it down. In this case, we're just going to write it down. Angle, side, angle. Okay. So just like in our notes, we talked about having leftover parts. And in this particular one, we know that BE will be congruent to DE, and then we're going to have AE be congruent to CE. And these are leftover parts after we have figured out which one of our 5 triangle congruencies would it be. And remember, all leftover parts that don't really have a reason why they're there are going to be because of C, P, C, T, C. Now, in our multiple choice, there's 2 of them here. On the test, there'll just be 1. Either one that you select and drag down will work, okay? But please make sure that you are familiar that this is what this means, okay? As you should be from our notes, and I'll show you in our notes where you can find another example that you can practice. All right? Then, of course, like always, you want to read and see what you have here. When we read this, it tells us that AC bisects BD and that BD bisects AC. Because these pieces bisect what we're going to be looking at, indeed, when we go to our multiple choice, it's something that talks about bisecting. And when we look right up here at the top, it says definition of a segment bisector, and that's exactly what that's going to be. Sorry. And there we have it. Now remember, I am explaining this all the way out for those of you who missed class or would just like to look at this again to study prior to the test. All right. If I am just doing it, of course, it will move a lot faster, but I want to make sure you have an understanding of why you're doing it. All right. The next one we're going to do is 4. I'm sorry, I didn't show you where to find this in your notes. So we did isosceles triangles, and then we also did a proof with that, proving proofs. So in your notes, you're going to go to solving proofs in your isosceles triangle theorem notes, and there you'll find the little shortcuts that I told you about trying to solve, and then also the 2 examples that we did together in class. So please review those to make sure that you have a strong foundation of what you'll be doing there. Okay, so right from your notes. So question number 4, how do we know the lengths of A, B, and D, E are going to be equal? And this is one that's not going to be difficult for us to do. Before we even try to answer the question, we want to look at the picture and see what was given to us. And indeed, we see that we have a matching pair of sides and a matching pair of sides. So I know that AC is going to be congruent to CE. And then I also know that, let's call that CB, is going to be congruent to CD. Okay. What we also know from looking at this picture is there's a set of angles there that we should know from prior knowledge. Making sure that we understand that this here and this here, these 2 angles, are formed when 2 lines intersect. The opposite angles are going to be congruent, and we remember those are congruent. We put our marking. We know that those are what we would call vertical angles. Okay. Because of these vertical angles, we know that angle ACB is going to be congruent to angle DCE. Okay, noticing always most important letter is in the middle. Now that we have our markings, if we just cover this up and look at one picture, we should be able to see that we end up with a side, angle, side. And when we look at our selection before, down for our multiple choice, we'll be able to clearly see that, the very first one is side, angle, side, and then the corresponding parts of congruent triangles are congruent. And so that's why AB would then be congruent to DE. Okay? Now, in your notes that comes from when we did proving triangles congruent, and of course on the inside of this, it should be a whole page. When we did our practice ones here, these 4 down here required a prior knowledge. This, of course, being prior knowledge from algebra, and then these 2, of course, being prior knowledge from earlier in geometry, your vertical angles. All right, we're going to continue on, and remember this has been slightly changed to reflect what you're going to see on the exam on the first. Okay, I gave a hint for this question here for you to actually draw this out. And while I'm doing this particular problem also goes back to the same set of notes that I just showed on that whole sheet of paper, where we talked about congruency statements, because congruency statements is going to be what's going to assist us. So we know that this up here, triangle ABC being congruent to triangle D, EF is what we would call a congruency statement. Okay, so we're going to use our congruency statement to help prove if these are indeed true or not. I did say give yourself a picture, that way you can see it. If you choose not to and you just go solely off of the congruency statement, I'm okay with that. But I just want to show you where your visual will help you a lot better, so that you don't get lost in the sauce with what letters you're looking at. As you can see, I put my markings on here based off of the congruency statement. Whatever A is, since it's my first letter, it should match up to D, which is my first letter in the second one. All right. Same thing with my sides. My first and my second letter is AB. My first and second letter in the second one is DE. They should be the same. I continue on. And now that I have this drawn, I should easily be able to determine whether each one would be true or false. So when I look at line segment AC, it has 3 markings, and I look at line segment FE, it has 2 markings. And based off of that, I know that it cannot be true, so it must be false. Okay. I look at angle B with 2 markings, and I look at angle E with 2 markings, and I know for sure that that one would be true. When I look at BC, BC is located here with 2 markings, and I look at EF, which also has 2 markings. Because of that, I know it will be true. Be careful, because this is one angle. We're looking at angle ACB. Always the most important letter is your vertex C. ACB. So that's going to be the one with the 3 markings on it right here. And we're going to pair that up with FE, and the most important letter, of course, F being the vertex that also has 3 markings, so we know that that one is also true. When we look at angle side DF and side AC both have 3 markings on it, and because they both have 3 markings on it, we know indeed that this is going to be true. All right, again, this came from the same set of notes in your journal. All right, well, we talked about the congruency statement right here and matched this up and listed our other congruency statements there. And we also took a great deal of trouble to make sure that we completed the congruency statement for each one of our matching sets here. So that's where you would find that information. All right. So on this one right here, This is a fun one, kind of like a puzzle. But once we put our puzzle together, you're going to see a lot of information that you already know. And we practice this during one of our Khan Academies as well. So we've got AC being congruent to AP being congruent to PQ, which is going to be congruent to QB, and all of these equal 8. When you make your markings on this, it really doesn't matter which one. It really doesn't matter if you put a marking or if you put a marking and the number 8. I'm going to put the marking and the number 8 on there throughout all of these, so that you can see where they are. Okay. I'm also going to read and see what else they give us, which is P, A, B. Remember, the most important letter is A. So when I trace P, A, B, I know that this angle here is going to be equal to 68 degrees. What they are then asking us to find in this particular puzzle is going to be BPQ, which is going to be located right here. All right. I'm going to call that X for now. X marks the spot. That is what we're going to try to find in our puzzle. When we look at this particular picture, there's a couple of things that we should notice right away. A lot of isosceles triangles have been formed here. There's one here, here, and here. But let's deal with the isosceles triangle that actually has something inside of it, an actual number. So when I cover this up like so, we should be able to see that we have an isosceles triangle. And based off of our notes, we know that if the isosceles triangle sides are congruent, then its base angles, its feet, right underneath it will be congruent as well. So since I know that this is 68 degrees, I also know that this one here is going to be 68 degrees. Okay, so I know that, and that's done. All right, so I'm just going to write this down just for your note purposes. Sorry, call that A, which is our original one, being congruent to. All right, we know that those two things are going to be congruent. Now, previous information from this course that you should remember, this angle and this angle here, which are adjacent to each other, and they equal 180 degrees. Adjacent and equal 180 degrees. We know the best vocabulary word for that is linear pairs. So these two angles are what we would call linear pairs. And since they add up to equal 180 degrees, the simple math that I need to do is just subtract. So I'm going to write this down and then, of course, do the math for that. All right. So we know that this angle here, PQA, plus this angle PQB will be equal to 180 degrees. All right. So of course we can do that simple math, but I'll do it here just to make sure that everybody has a good understanding. That was the 68 plus angle PQB, which we don't know, equals 180. We would subtract that 68. And of course we'll end up with this angle PQB being equal to 112. Okay. I hope you can see the puzzle that's coming along here. Now you might be saying to yourself, oh, we've got something good going here. We're cooking with grease. And you're absolutely right, because now we have moved into the triangle that has our X. X is the spot. That's what we're trying to solve for. So I'm going to turn my picture around so that everybody can see the isosceles triangle that is formed. If I cover this up like this, you'll be able to see, maybe a little bit more like so, you'll be able to see that we have an isosceles triangle again because of our markings, marking here and here. All right, so it's the same rule. If the sides are congruent, just like I said before, those base angles are also going to be congruent. So if this is x, then I know that this also is going to be x. Now, let's just go ahead and give these 3 markings, just for the sake of it, since we've already used 2 markings here. All right. So I'm going to flip my picture back around. And of course, we already know, y'all, that the sum of a triangle, which also we went over in this particular lesson too, the sum of a triangle equals 180 degrees, but that was a review. We've been talked about that, but it's also included in the notes for this section. So what I'm going to do is take this angle plus this angle plus this angle and set them all equal to 180 degrees. So let's start off with angle. P QB, which is here, PQB here. And let me add it to this angle here. I'm going to call it angle PBQ. And then, of course, angle BPQ. And in this case, we know that it equals 180 degrees. Okay, so remember that angle PQB is going to be 112. Then, of course, the other 2 we know are going to be x. And we know equals 180 degrees. Okay, in a minute, we'll go ahead and discuss something you're probably thinking like, ma'am, we really don't have to do all of this, and you'd be right. But of course, like always, even in class, I want to make sure that you have a deep understanding of what it is that you're doing. So no matter what the numbers are, no matter what the picture is, no matter what the work is, you'll be able to succeed. Okay? So we know that x is going to be equal to 34 degrees. Now you're probably thinking all we had to do was take 112 and subtract it from 180 and divide by 2. You're absolutely right. And that's what we did. We subtracted 112 from 180 and then we divided it by 2. So that is what we just did. So your answer for this one would be 34. It's a puzzle. You need to take the time to solve your puzzle. Although there will not be one that will have 2 triangles like this on the test, what you will have on the test is one where there will be at least 1 triangle like this. Now, when we look closely at this particular triangle anyway, we're only going to be dealing with 1 triangle in the first place. Sorry about the gritty numbers, but we'll go ahead and work on this one. Okay, so again, when you see this on the test, you won't have a distraction of a second triangle. You'll only have the first triangle. Okay, so it says determine the measures of each of the interior angles, and then we need to classify the particular triangle by its angles. So when we go ahead and we read through this, they're asking for 3 different angles right here. If we are careful, we know we all should be looking at the vertex, the letters in the middle, to determine what is what. But we can't do anything until we actually solve for the variable. And just like I said before, I forgot to show you where these notes are. That's how you know that's not usually what I don't do that in class, but I should. Okay, so sorry, going back to the other one, we talked about the isosceles triangle theorems. So in the isosceles triangle theorems right here, this is where they are located. So remember we talked about here, if the sides are congruent, then the base angles are congruent. And then of course the converse of that, if the base angles are congruent, then the sides are congruent. We did some examples down below, and we'll come back to this one again. and talking about the sum of the triangle. We did that when we talked about classifying triangles at the beginning. And then down there at the bottom, there it is the angle sum theorem, which I told you is also called the triangle angle sum theorem. And of course, we've learned that already, but this is just to show you again. All right, and I'm not coming back to this page because this is the same one that we're going to use for right now for question number 8. Okay. So this is going to be 3x minus 18 plus x plus 7 plus x minus 9 equals 180 degrees. Okay, so of course we're solving for the variable, so we're going to go ahead and combine our like terms on one side. We end up with 5x. We go ahead and combine, sorry, that should be a box. We go ahead and combine our numbers on both sides, and do so should be negative 20, negative 11, negative 11, and 9. And then, of course, bring down the 180. Inverse. Ooh, we need to add. Bring down our 5x. Inverse of multiplication is division. We should end up with 40. Okay. So now that we have x equals 40, it is nothing to do with the particular answer itself, but we do need it to solve for each one of the 3 angles. So when we look at the very first one that they ask us for the measurement of CBD, we come back up to the picture and we trace CBD. So we know the angle that they are looking for is located here. So I'm just going to write right here, the measurement of angle CBD was equal to 3x minus the 18. We already know what x is, so we plug that in. Okay, and then of course once we plug that in, we get the 120 minus the 18, which gives us 102 for this one. Okay. Okay. All right. We keep going and we look for the next one, which is BDC. So when we trace that, we go BDC. So what's in the place of BDC? X minus 9. So of course we know that's just 40 minus 9, and that gives us 31. Okay. And then of course in the last one, BCD, we go back up here, BCD, and of course the measurement of angle BCD was equal to x plus 7. And of course, just simply fill that in. 40 plus 7, we get 47. And of course, after doing all of this, the last thing that they ask us to do is determine what kind of triangle is triangle CBD. So when we go back up to the top and we look at that, if I cover this up like so, and I'm looking at only triangle CBD, I should be able to determine what kind of triangle it is. So I'm just going to fill in. Okay. So again, we know what kind of triangle it is by going to our classifying, and I said I was going to come back to it, but at the top of the classifying the triangle notes here, remember we talked about classifying it by the angles, which is up here at the top. Okay, So in this case, we know it to be an obtuse because it would be one angle that is at least greater than 90 degrees. And then, of course, the size below, but they're not asking about the size. So in this case, we can only identify it based off of that, and we know that this would be, of course, an obtuse triangle. And that is where you find it in your notes. And question number 9, you need to graph that first. And of course, in graphing, you're going to be able to produce a beautiful picture, and then of course that picture will help you determine what what we're asking for here. So go ahead and graph if you haven't graphed already. And it'll be a good idea to graph and label. Okay, so what I've graphed first is the triangle. So I'm going to come back and then graph D after I trace this, okay? So usually I take some kind of straight edge, a piece of paper of some sort, and just connect. But this time I'm just going to try to do so like this. I would definitely suggest if on test day, if you don't have your own graph paper, then those little quarter of a sheets of graph paper that I leave out, please make sure that you grab one, or maybe one is enough, one of those, so that you'll be able to do the graph work for this one. Okay, now I'm going to graph D, which is at 0, 2. Like this. All right, so they're asking us to calculate the area. We know the area formula is equal to a half times the base times the height. All right, and they're telling us that we are given the altitude. Remember in our notes that another word for altitude, of course, is height. So we know that the height of this is going to be CD. So if the height we already know is CD, then we know that the base has to be AB, because it has to touch the base if that's the height that we're going to be using. So let's first, okay, since they gave us height in the form of altitude, we know that the height is going to be CD. We then know that the base is going to be AB. Okay? And now that we have those two things, we got to find them, because right now we can't just count and find them. We actually have to do some math work. So the math work on this is one or two things. You can use the distance formula from A to B using those 2 points, or you can use our A squared plus B squared equals C squared, which is what I use most times when we are given a graph. Okay. So what I'm solving for now is AB. Remember, it never matters which one comes first or second. It will work itself out in the end. Now, because in our answer they ask us to round to the nearest tenth if necessary, then in this case here, when I put this in the calculator, I'm going to get 9.4, which will be to the nearest tenth. But I need to round to the nearest tenth at the very end. So what I need to do is also write the number that comes right behind it, which is going to be 3. Okay, so make sure that you write this down. Okay, so now that we have that, we're going to do CD. Now CD is the same thing. We've got to be able to find the length of this. And again, if you're good with the distance formula, go ahead and put in your points for C, put in your points for D. If not, then we're going to graph this out again to see what is going to be the length of the line. So here we're going to have 3, and here we're going to have 4. So now that we have the 3 and the 4, we're going to put that into our formula, which is going to be 3 squared plus 4 squared, and that will be equal to C squared. So again, you should already know the answer to this, because any triangle that we deal with, that is what we call one of our Pythagorean triples. If we have a 3, 4, then we know the hypotenuse will always be 5. But we'll do the work to prove that. Okay, so now that we have what we need to fill into our formula, we have the base and the height. All we have to do is put this successfully into the calculator. Now, if you put half in the calculator, there's 2 ways to do that. You can put it in as the 0.5 and then multiply it by the other 2. Or, of course, you remember, I'm going to write this over here. It's the same thing. You can do the base times the height, and, of course, then divide by 2. It's going to give you the same exact answer. Now, when we put this into the calculator, you have to be careful. You're going to end up with 23.57, but rounding to the nearest tenth means that we need to put 23.6. Now, you have to do that, or it's going to end up as an incorrect answer. Where do you find this in your notes? When we did triangles on a coordinate plane, we went ahead and graphed on this side here, and then on the other side, we actually did the area and perimeter. But on this particular one, we are just doing the area. So remember the height, altitude. Okay, so that's where you find those notes in your journal. All right. This one again is going to be a side angle side one. We talk about what's congruent to what. So when we look at this initially, the first triangle is a little weak. It only has 2 things, just the side and the angle. We want to match them up with our congruency statement. So we look at LM, which has 8, and OP, which has 8. So we know that they are congruent because it both has the same amount. We also know that it's congruent because if we look at the congruency statement, L and M is the first and third letter, Q and P is the first and the third letter. So we know that those sides are congruent. M, I'm going to give one marking here. They're both 60. We see it when we go over here to our picture again. We look at M, which is the third letter, and P, which is the third letter. So that does match up. They're asking us to locate the missing information to prove that this is side, angle, side. Well, in this case, we have a side, we have an angle. We are missing a side. There's only one side that it could be because the angle must be included. It must be KM. Now, what side does KM match up with? When we go back to our congruency statement, K is the middle letter, M is the last one. Same one here, we've got R and P. When we look at R and P, it's located right here, which is 9. So that means that KM must also be 9. We easily look at our multiple choice, and we select the only one that it could possibly be. And just like that, you are done. Again, where you would find this is when we did our congruency statements and we talked about what was congruent to what inside of our notes and proving triangles congruent. Number 11 is another type of puzzle. When we look at this right away, you might be thinking to yourself, so I have no idea what to do, but I do see some markings. If you see these two markings right here, already you know that that particular triangle is going to be what we call an isosceles triangle. I'm going to turn this so that you can see it a little clearer. So again, just like in our previous ones, if we know that our side angles are going to be congruent, if we know that our sides are going to be congruent, then in the isosceles triangle, our base angles are going to be congruent as well. So easy for us to answer right away. Angle 1, of course, is going to be 69 degrees. Okay. So now that we've got that filled in, we can continue and say, hey, how can we find angle 2? Oh, yay. So then in angle 2, you can easily find that by the sum of a triangle. So we know that all three of the angles should equal 180. So that's not what I wanted to put. As you can see, I was distracted by my messages coming in. Okay, so when we add that together, that 69 and 69, of course we should get 138 plus angle 2, and of course that'll be equal to 180. We subtract that, and the measurement of angle 2 is going to be equal to 42. Okay. So again, when we look at angle 2 and angle 3, this should look real familiar. We've done this one before in the previous one. When we look at that, we know the relationship for these two is that they are adjacent and that they add up to 180 degrees. And in this particular case, that we know angle 2 plus angle 3 will equal 180 degrees. So that's how we're going to solve for that. Okay. I think I'll use the space down here. Now, another rule that you might remember is that this angle 3 is also an exterior angle, and it will be equal to the two remote angles here. So whichever way you want to play it, you're going to get the same exact answer. And that's what's important, for you to have multiple ways to get the right answer. So the measurement of angle 3, once we subtract that, of course, will be 138. No surprise there. We've already dealt with that number. All right, and then we look at our little itty bitty tiny triangle here. And when we look at that, then of course, everything's filled in now except for angle 4. So I'm just going to cover it up like this so we can just look at this particular triangle only. And when we look at this triangle, what we are going to see is that the sum, again, of the triangle is 180. So we're going to do 14 plus that 138 plus angle 4. And of course, we know that the sum of any triangle equals 180. So now that we have that here, then we're going to add these two together, which we should end up with 152 plus angle 4 equals 180 degrees. We're going to subtract that. And we know that angle 4 should equal, once we put this into the calculator, 28 degrees. Okay. All right. So very good. So again, this is the isosceles triangle notes. Again, isosceles triangle notes. And then, of course, coupled with our notes from identifying a triangle, and also our isosceles. No, oh, I showed that already. My bad. All right, so here we go. We've got another one here, number 12. And number 12 asks us to solve for x. But there's no way we can solve for x until we set up an equation and realize what kind of angle this is. And when we look at this angle here, we notice that this is what we would call our exterior angle. Please make sure that you write exterior angle here. So exterior angle, or just exterior. And that is the notes that you're going to use for this. So remember, we talked about this before, this exterior angle being equal to the furthest remote two angles inside of the triangle. Okay, so when we do that, it is written as 19x plus 3 equal to 9x plus 16 plus 6x plus 15. Okay. Remember, on the left side, there's nothing for us to combine, so we'll just bring that 19x plus 3 down. But we'll go ahead and combine the 9x and the 6x. And of course, we end up with 15x. And of course, we'll combine the 15 and the 16, which should give us 31. At this point in our algebraic equation, it doesn't really matter what you move first. It's totally left up to you. I'll go ahead and move this 3. Inverse operation cancels out, bring down the 15, and then of course this is going to be plus 28. I'm going to subtract the 15x because it's the only thing that I can move without creating more work for myself. Okay. And then of course dividing both sides. X is going to equal 7. They asked us for x, we delivered. Bam! Now, the next thing they ask us for is BAC. We have to look at our picture and we have to trace BAC. When we trace BAC, the most important letter is going to be A. So what we are looking for is this angle here. There are two ways in which you can answer this particular question. You know that the sum of a triangle is equal to 180, so you could fill into those other two angles and then subtract, which is the longer way to do it. Or, since we know that the exterior and the interior angle are these two angles that are adjacent to each other and equal 180 degrees, linear pairs, we can set that up and solve that way. And that's the way I'm going to choose, as I feel that is the easier way to do that. So first, before we do anything, we need to know how much this exterior angle is. So the exterior angle is going to be equal to 19x. We know that x is 7 plus 3. Okay, and doing that math, we should end up with 136. So this exterior angle is 136 degrees. All right. To go ahead and solve for this, we know that angle BAC plus the exterior angle of 136 is going to equal 180. And the simple mathematics to that is just to subtract the 136 from both sides, and then you get 44. Okay, so 44. I don't know what happened with my focus there, but we'll go ahead. Okay, there you go. Move to the next one. And again, that last one on the exterior angles comes from our classifying triangle notes at the very beginning when we talked about the exterior angle here adding up to the two remote angles. Okay, number 13, I did ask in the original one that we did, if you just draw it out, you want to draw the isosceles triangle and make a representation for the legs. And the reason we're calling it legs is because that's what it calls it in the problem. It tells us that the base is 9.5. And then what we're trying to do is figure out the perimeter of just one of the pillows. So for us to be able to figure out the perimeter of just one of the pillows, we need to, of course, I'm going to write it down, perimeter of one pillow. We need to look at the lace that we have, which is going to be 380. And then we need to look at the number of pillows that we're trying to make, which is at least 8. So I can divide that by 8. Okay. So once I do that, the perimeter of one pillow is going to be 47.5. For me to go ahead and figure out what the leg or what the maximum length for each one of these legs could possibly be, I need to go ahead and write out that 47.5, right? And then what I need to do is then put that equal to the perimeter, which is going to be L plus 9.5. Okay, so this is what we're going to do here. So of course, now that we have an equation, we can bring down our 47.5, combine our like terms, and then go ahead and subtract. Inverse operation, they cancel out. We get 38 equal to 2L, and then of course we need to divide both sides by 2. Okay. So in doing that, we know that one of our legs would be 19, which of course would be C in this case. Okay. Now, were there other ways that you could have done that? Absolutely. Any other way you see fit. Once you find out the perimeter of one pillow, then you can multiply each answer choice by 2 and add the 9.5. You could multiply everything and make it big if you wanted to. I mean, it really doesn't matter. I think this is the most straightforward way. Okay. The last one that we're going to do is number 14. All other questions that I did not go over will not be on the assessment. So 14 is the last one. Oh, and where to find this? Again, if you guessed it, isosceles triangle is a triangle of the year. Not the year, but it's the triangle of this test. There's a lot of isosceles triangle stuff going on, so you're absolutely right. Turn to those notes. So on the back of this, where we have the isosceles triangle, there is a problem down at the bottom, just like that one. Okay. And then in this last one, this is going to be our perimeter one. So we've got perimeter and we've got area. And in this one here, the first thing they said, if the perimeter of the triangle is 173, we know the whole thing is equal to 173. We need to find the value of x. So of course, to do that, easy peasy, we just need to set up the equation and solve. The equation means that all three sides are going to be equal to 173. Let's combine our like terms. It should give us 18x -7. Okay, so we have x equals 10. So we solve for x. The next thing that they ask us to do is come up with the area. So we get lucky because it's a right triangle, and based off of our notes, we talked about going from the vertex to a perpendicular bisector. No, perpendicular meaning a right angle. So of course this side is going to be perpendicular, these two lines. Okay, so either way you can call height our base, it doesn't matter. Let's just use this for the base as it's the bottom, and use this for the height as it is over here on the side. Okay, height. All right, so all we have to do first, of course, is plug in our x value with what we have, which is 10. Okay, so once we do that, we should know the length of our base and our height, and then of course we're going to plug that in. All right, so we should end up with 62, and we should end up with 51. Now, from our prior studies, we know that the area is equal to half the base times the height, or height times the base. They can be interchangeable. All right, and when we put that into the calculator, it should give us a clean 1581. And of course this is going to be inches, so it's already noted for us, inches squared, so we'll just fill this in. All right, and that is it. There are no more questions here. Please make sure that you review your notes again. Where would you find this? In the area and perimeter notes that we took. So area of a triangle and perimeter. Okay, that's where you find this particular one at. I would ask that you review everything, and the last thing that I would say to review is to make sure that you understand these. Okay, there'll be one question that we'll go over Monday that will be similar to this one here, all of these. So make sure you understand side, angle, side. Make sure that you understand angle, side, angle, HL. Make sure you understand all 5 of the triangle congruencies. Okay? All right. Thanks so very much. Please make sure that you watch as many times as necessary to ensure that you get the bomb grade on our assessment on Tuesday.